experiment conducted on April 8, 2019 by Lab Group A4. Let's move on to the first slide. Motivation. Through this experiment, the lab group sought to analyze the dynamic behavior of both acoustic and pressure waves present in a Rijke tube. Let's move on to the next slide. So, to properly understand the experiment conducted, it's important to understand what a pulse combustor is. Pulse combustor is a combustor that produces a periodically fluctuating pressure wave, similar to a sine wave or a cosine wave. However, a pulse combustor also generates a fluctuating acoustic velocity. These acoustic oscillations mutually reinforce and facilitate heat release until such time as said heat release is balanced by acoustic losses. Let's move on to the next slide. Now, a Rijke tube is a special kind of pulse combustor, typically mounted vertically, that is open at both ends. A heating element is placed roughly a quarter of the way from the lower end of the tube. When acoustically excited by a heating element, a Rijke tube will produce a standing wave with a node at either end of the tube. Bear in mind, a node is a point of minimum amplitude or zero amplitude, and an antinode at its midpoint. It's important to be able to visualize a wave similar to a standing wave on a rope, similar to an experiment often conducted in high school physics classes. When heat is added at a point where the signs of pressure and velocity are the same, and when heat is added in phase with the pressure wave, the addition of heat will drive the pressure oscillation. Let's move on to the next slide. Experimental setup. This experiment was conducted with a 1.79 meter Rijke tube. The lower end was open to the air, while the upper end was connected to a pipe that simulated atmospheric conditions while muffling sound. The Rijke tube contained a propane burner that could be moved remotely throughout the lower half of the tube. The tube was fitted with 3 piezoelectric pressure transducers, each spaced 0.46 meters apart. The first pressure sensor was located in the middle half of the upper half of the tube. The second pressure sensor was located roughly in the middle of the tube, and the third pressure sensor was located in the middle of the lower half of the tube. Once again, each of these pressure transducers was spaced 0.46 meters from the adjacent ones. Additionally, the tube was fitted with a photomultiplier mounted behind a quartz window. Let's move on to the next slide. 2 kinds of sensors were used in this experiment: piezoelectric pressure transducers and a photomultiplier. The pressure transducers used the piezoelectric effect to produce a current that could be measured, and the photomultiplier used a cathode and anode collector to record a current generated by excited photons, or rather, by electrons excited by incident photons. Let's examine the procedure we used and move on to the next slide. Firstly, the dimensions of the Rijke tube were determined, and piezoelectric transducers were fitted to an oscilloscope. The Rijke tube was then flooded with air, and instrument function was visually assessed. The burner was moved to the 6-inch position where a flame could be observed when ignited, and it was ignited. The valve was checked to be closed, and the photomultiplier was connected. The burner was then lowered to its first position, and the photomultiplier was connected. Then data from the photomultiplier and the pressure transducers was connected at the 0-inch position with the valve closed, the 2-inch position with the valve closed, and the 5.5-inch position with the valve closed. It's worth noting that the 5.5-inch position was determined experimentally. The burner was raised until such time as the audible humming that had pervaded throughout the experiment stopped. The burner was then lowered to 0 inches, the valve opened, and more data collected. Let's move on to the next slide. Here you can see the frequency results and the amplitude results. Clearly the frequencies tend to be roughly 20 Hertz, and the amplitude roughly 125. We then determined the estimated resonance frequency to be 96 Hertz from the equation that you can see at the bottom of the page. Additionally, the phase angle relative to the photomultiplier was determined by finding the difference between the phase associated with the piezoelectric transducers at their respective positions and the photomultiplier. In conclusion, the frequency and amplitude of a Rijke tube can be easily collected. The amplitude of a Rijke tube used in this experiment is 124 decibels, well above the human hearing threshold. The estimated resonance frequency of said Rijke tube is 96 Hertz, well within the accepted human hearing range of 20 Hertz to 20 kilohertz. Thank you.